Hi friends, my name is Narasimha and I'm studying CSE Data Science in IRE College. Today, as a part of my AAT concept videos, the subject of data structures, I want to share a few knowledge regarding to the topic named demonstrate pancake sorting. So let us get into the topic. First of all, what is meant by sorting? In a computer science, a sorting algorithm is an algorithm that puts elements of a list into an order. The most frequently used orders are numerical order and lexicographical order and either ascending or descending. First of all, coming to the word sorting. Sorting means to arrange the elements of a list in a particular order, which may be in ascending or descending or the required manner of the user. So, sorting is also often useful for categorizing data and for producing human readable output. For example, unsorted list. In the list, I have taken random numbers 2, 1, 3, 4. This is an unsorted list. While we sort the list and the output will be as the sorted list is equals to 1, 2, 3, 4. So now, what is pancake sorting? There are many algorithms in programming language for sorting process. One of it is pancake sorting. Not only pancake sorting, there are many algorithms such as insertion sorting and selection sorting and different types of sortings. One of the topic which we are going to explain today is pancake sorting. In this algorithm, a kind of selection sort, we bring the largest pancake not yet sorted to the top with one flip, take it down to its final position with one more flip and repeat this process for the remaining pancakes. By listening to the theory, it will be somewhat difficult to understand, but I will explain in the further slides in a easier manner. Here, I am going to say that in this algorithm, every sorting, not only for sorting technique, for every technique in the programming language has its own algorithm. And this is pancake algorithm, a kind of selection sort technique is used. Now, flip. In pancake sorting, one most important function to do in a source code is flip. In pancake sorting, flip is an important task which I have explained before. Flip means reversing. For example, let us assume a list capital A is equals to 1, 2, 3, 4. Now, after applying the function flip, flip capital A, 3 is equals to 4, 3, 2, 1, which means reversing of the whole list. Here, the function flip takes place from 0th index to the 3rd index of the list A. Because in the function flip, we have given the arguments as capital A, which indicates the list variable, and comma 3. 3 indicates the index position of the list up to which the element should be reversed in the manner. Now, let's get into our topic, pancake sorting. Here, I'm showing an example and I will explain in detail in this slide by which you will get an idea about and a clarity about the pancake sorting. First of all, let's see the first picture. Let us assume the elements of the picture as a list. Now, while we see the first picture, you can see the elements as 3, 5, 2, 1, 7, 6, and 4. Here, the length of the list is 7 and the element which is maximum of the whole list is 7. So now in pancake sorting, same as in pancake, who will prepare the pancake and who want to sort it from top to bottom in an ascending order, same technique we are going to use in pancake sorting. So now let us pick out the maximum of the whole list, and 7 is the maximum number. So now up to 7, you flip the list, and here you can see that here is a 7 number, and from 3 to 7 I want to do a flip, because as we all know, I'm sorting in an ascending order. The 7 should be in the last as a last element. So now first we will flip the 7 to the top and 3 to the down, and we'll reverse whole the list. So now after doing the first flip, we will get a list there in the form of second image, that is 7, 1, 2, 5, 3, 6, 4. 6 and 4 are the same positions as we had not invented them into the flip function. Now flip all the list, because as I have said before, the 7 is the maximum number and it should come at the last. After flipping whole the list, we will get into the third picture, that is 4, 6, 3, 5, 2, 1, 7. Now 7 is the last position and we will ignore it in the other flips, because I have said before that we will use the selection sort technique in the pancake sorting. So now we are assuming the list by excluding 7 for further sorting process. Coming to the flip 4. Now the 6, now the element which we have to arrange before bottom is 6. As we all know, in the flip 4, in the flip 3, 6 is in the second position. So first we have to make 6 in the first position and we have to reverse whole the list. Now 6, for bringing 6 in the first position, we are flipping 4 and 6 and it will become the flip 4. You can see the 6, 4, 3, 5, 2, 1, 7. Now excluding 7, we have to flip whole the list. Now we can see in the flip 5, it will convert to 1, 2, 5, 3, 4, 6 and 7. Now coming to the third element to be arranged, it is 5. Now we have to bring 5 to the first place. So we have to flip the elements from the 0th index to the number 5 index. Now we are flipping the elements. Then the list will be modified as 5, 2, 1, 3, 4, 6, 7. Now flip the whole the list excluding 6 and 7. Now we can get 4, 3, 1, 2, 5, 6, 7. Now we have to arrange the number 4. And for that already we have to flip the 4 to the first position. And next we have to flip whole the list. And coming to flip 8, we have to arrange 2 into the second position. As we all know, 2 is already in the first position. So just flip 1 and 2. Now we can see the list is in the sorted manner 1, 2, 3, 4, 5, 6, 7. This is a sorting technique to be applied for pancake sorting process. The simple algorithm which we are using in the pancake sorting is, first of all, we have to know the length of the list, and next the maximum of all the elements, the maximum number from all the elements we have to identify. Next we have to flip the list up to the maximum number to the top. Next we have to reverse the whole list. In the same way, after arranging the last element in the last place, maximum element in the last place, we have to exclude the element from our next sorting process, and we have to repeat the process which we have done for maximum element to be arranged. I want to show in a simplified manner of all the flips. This is an array visualization of above diagram which I have shown before. This is an array visualization. Initially, the pancake order is in this format, in the list format 3, 5, 2, 1, 7, 6, 4. After doing first flip up to 7, which I have said before, after first flip, the list is modified as 7, 1, 2, 5, 3, and 6, 4 are as it is. Next, for doing second flip, we have to reverse whole the list. So, after getting second flip, the list is modified as 4, 6, 3, 5, 2, 1, 7. 7 is in the last place, so we have to exclude the 7 from further sorting process. And coming to third flip, our third flip, it will be modified as this. And after fourth flip, this. And coming to the fifth flip and sixth flip and seventh flip. And at last, eighth flip. After eighth flip, we will get the required manner of an sorting list, sorted list. That is 1, 2, 3, 4, 5, 6, 7. Not only in ascending order, we can also do it is in descending order. That is, after doing the ascending order, at last, if we flip whole the list, then we will get the organized manner of the descending order of the list. Otherwise, instead of selecting the maximum element of the list, we can select the minimum element of the list and follow the same steps which we have followed before for arranging the whole elements in the list in the ascending order. Next, coming to the complexities. Worst case time complexity is order of n, average case time complexity is order of n, and space complexity is order of n. As I've said before, first we have to identify the element and put it in the top place, and next we have to flip all the list. If the element is already present at the top, we don't need to do two flips. Actually, to arrange the element in the required position, we have to require two flips. That is, flipping the element to the top position and again flipping all the list. If element is already present at the top position, then we will require only one flip. That is the best case, and two flips is in worst case. This is the complexity which I have shown. And now I will recall all the techniques which have been said. This is sorted process and the pancake sorting. Once again, I want to explain the algorithm. In this algorithm, a kind of selection sort, which I have mentioned before, we are excluding the elements which is already sorted, and we are doing sorting process for the other elements which has to be sorted. So we are implementing the selection sort, moving the largest pancake not yet sorted to the top with one flip, which I have said before. Take it down to its final position with one more flip. Which I said before, two flips are mentioned in this theory, and repeat this process for the remaining pancakes. As I explained the whole list in the diagram, and this is a definition for the pancake sorting. So these are the complexities which I said before: worst case time complexity and average case and space complexity. And the applications. For any sorting process, there should be some applications, and it should be unique for all sorting process. For pancake sorting appears in applications in parallel processor networks, in which it can provide an effective routing algorithm between processors, which will be useful in computer world. It is also used when the only allowed operation to sort a sequence is reversing. When there is a question or a program that we have to sort the whole list and we have to use only one function, that is reversing, in that case pancake sorting is very useful for us to do the sorting process. So thank you friends, and I hope my lecture is useful for you, and thank you for listening.